Hey, Mr. Hallam here. So, can you? Can you take this paper? Any standard size paper? And fold it in half? 7 times? Can you do it? Did you get it? Does that count? Let's add the math. No folds. 1 section. 0.005 inches thick. One fold. 1 section. 2 sections. 0.005 plus 0.005, 0.01 inches thick. Write it down. Two folds. 1 section. 2 sections. 3 sections. 4 sections. Can you fill in the rest of the table? Do that. Should have got a table like this. So now what we're going to do is we're going to take that data. We're going to find the model that models the paper folding. Yep, there's a model for that. But before we do, let's see if the Mythbusters could fold it more than 7 times.
Back over at NASA, our team is finding out that folding a football field-sized piece of paper isn't exactly a breeze.
For instance, the fact that it turns into a giant windsock with the littlest bit of a breeze. There's air trapped underneath it.
But they managed to rein in the billowing parachute without any tears for an official Fold 1.
Let it fall. Pull the slack. Oh, that was beautiful.
They reposition for the next crease.
We're going to fold that direction.
It's like trying to fold the world's biggest bed sheet.
It's crumpling in weird ways. It's not folding smoothly.
But the team manages to smooth out the wrinkles and make folds 2, 3,
Hey, notice we're all getting a little closer?
4, 5,
Everybody to this side for 6.
and 6. Neat and tidy tuckings.
It's actually like an airbag.
However, with each pass, the additional layers make it harder to heave over. And at Fold 7, everyone and everything is starting to puff.
A lot of air. Yeah, and it's not going down. There it is. Yeah, push your foot.
7 is squashed out. Now, the team is about to go for 8. If they achieve this, they will bust the 7 paper fold myth.
See how everybody's very quiet? Because we're all anticipating busting this myth. We folded it 7 times. We're about to go for number 8.
Number 8. Looking good. I think we're going to do it.
The paper tries to dig in its heels, but is losing its grip.
Come on.
And we did it!
Yeah! 8! 8!
It sure feels satisfying to beat a paper myth to a pulp.
If you draw a line all the way down, you'll be able to intersect every layer, and that is a true 8 folds. And that busts this myth.
There's no stopping our out-of-control paper pushers now. If it's worth doing, it's worth overdoing. Carry trucks in a giant rolling pin to flatten this piece of puff pastry some more.
Flat as a pancake!
As smooth as rolled dough, it folds back easy as pie.
9.
9!
To achieve double digits, the paper is too heavy for the team to lift themselves, so they stick a fork in it.
Drive in. Drive in.
That is a definite 10.
Topping 10 is going to be tough. Thanks to their buddy Exponential Growth, the paper is now 1,024 layers thick. It takes every ounce of strength they have to bend it.
You got it?
That feels like an honest 11 to me.
Nice!
Not only did they bust 7 folds, they turned it up all the way to 11.
Definitely put this one to bed.
Absolutely.
Well, as far as our definition for the myth goes as the fold, we've got it long, we've got it flat. If we do any bit more, it's just going to be a semicircle. We got 11 folds out of a football-sized piece of paper. We busted a myth, and we're going to go home before the sun completely goes down. 11 folds.
I didn't think it was possible.
Should we go to the NASA gift shop?
Woo!
Yeah.
Okay, so now that you know you can break the record of 7 folds under special cases, then what I want you to do next is to graph this so that we can see how many folds we can actually do. We can write our model. All right, that's our goal. So take this data in this table with your independent variable being your x, or your number of folds, and your dependent variable, your y, or the number of sections, and I want you to graph it. So what I want you to do is I want you to put it on this graph here. So label it. The axes are already labeled for you. You figure out your scale, and then once you put it on there, we've done this family of function stuff before. What I'd like you to do is to figure out which one you think this belongs to. Shouldn't be a mystery. I'll give you a little hint. Should look something like this. If you'd like to check and make sure you did everything right by going to Desmos, you're more than welcome to, but you do need to duplicate this with the correct scale on your actual notes. So that's your homework for tonight. We'll see you tomorrow where we actually create the model for what we're doing in class, or doing in the video now. All right, see ya.